Alright, hey guys, so we're going to start going over the Matlab code section for this remote control car lab. This is the code that you're going to be able to receive input by through Matlab, through the command window, and this will send your code to the XB on your remote control car. So we're going to go through this section by section. First section, we're going to declare some global variables. We're actually going to go over this last because you'll see later on why some of these variables need to be global. So in the second section, you're going to set up your serial connection with the XB. To begin, you're going to eliminate any ongoing serial connections that might be being used by other applications like your Arduino program, and that just clears things up for Matlab. It eliminates any issues with your serial connection. Next up, you're going to declare the variable called S. You're going to initialize this using some COM port. You may have to look on your Arduino program to see what COM port you're using. In our case, we're using number 10, but you can go to the Tools toolbar, look at port in your Arduino program and see which COM port you're using. These next 4 lines are pretty standard. You probably won't have to change them. They're just initializing things like your baud rate. It's 9600 like we've been using before. You're going to open the COM port that's stored into the variable called S, and then you're going to read in, this is actually a type of library that you're going to need to download. It's called Hebe Keyboard. What that does is allows keyboard input into Matlab. You'll see why we're using that a little bit later on in the code. This is the line where you initialize it, and you'll have to download it. We'll give you a link in the video description of where you can download that. This timer section, there's a fancy and really handy function in Matlab called timer. And what it does is it's a type of loop, it's a type of function that runs every certain number of seconds. So in this case, it's a function that's going to automatically be called every 1/10 of a second. The function is called transmit data. That's something that we actually declare at the end of our code, so we'll go over it near the end. So once we declare it, we're going to start it, and then from that point on, every 1/10 of a second, no matter where you are in the code that's being run, it's going to run this function. So we come to our main loop, and remember that to make this car run, we're going to be pressing certain keys on our keyboard, and that's going to be commanding the car to be doing certain things. So we're going to be using primarily keys A, W, S, and D for directional controls, and then numbers 1 through 9 for speed control. Basically, you see that there are a series of if statements, one for each letter that's being sent to the XB. And the way that you can read those letters are by calling KB, which we declared up above for the Hebe keyboard, and assigning that to a variable called state. And then you can say if state.keys is equal to a certain letter, you're going to assign that letter to the variable called letter. And you can see we do that for each letter that we want to be able to press, W, A, S, and D, and then 1 through 9. We also have a command that says that if you press the escape key, it's going to send the letter Q. And what that does is when the car, this is in the car code actually, when the car receives the letter Q, it basically escapes the program. So that is the main while loop. This program is going to be continuously reading in what key you're pressing on the keyboard. And as I said before, that timer function, this is actually why we need our global variables, because we're referencing variables that are in our main Matlab script, and those same variables are actually being used in this function. So that's why they need to be declared global. And that's why we declare them at the top of our code up here as global. So this timer function, it re-references those global variables, S, letter, and finish. It's going to display the letter on the command window, the last letter that you pressed, and it's going to print that letter to the serial monitor, and that's the serial monitor that your XB is hooked up to. All you have to do is use the fprintf function, and if the letter is Q, like we said before, if you press the escape key, it's going to reset the variable finish equal to true, And that, remember, this while loop up here is if finish is false, it runs the while loop. So if finish is true, it basically terminates the Matlab program. And it reassigns the letter the variable letter to n at the end of each time that the timer function iterates. And so that means basically any time that you're not pressing a key or no key is being held down, it's going to send the letter n. And when the car receives the letter n, it's not going to do anything. So long story short, the car is only going to be actually doing something when one of these letters or numbers are being pressed down.
Hello everyone. Today we're going to talk about how to take keystrokes and turn them into serial commands using a simple Python script. To begin, you need to import these two libraries, the serial library, which you're going to be using to send to the serial port, and then the tkinter library, which we're going to be using to log the keystrokes and establish the GUI. So first thing we're going to do is we're going to declare our tkinter variable as root. Then we're going to define our geometry as 500 by 300 and then our title. Once we've done that, we're going to go ahead and create a label, which is just the tkinter.label command. We're going to set its geometry within root here, and then we're going to give it this little bit of text to make it a bit clearer what its purpose is. Once we've done that, we're going to define its geometry using the pack function within the greater root geometry. Once we've done that, we're going to create this little key function. The key function will essentially take these event.car variables and then assign them based on which key is pressed. For example, Q will be used to trigger the root.quick command, which will close out the GUI. For everything else, it's basically going to take whatever is pressed and then output it using this print command as the keystroke. Once we've done that for all of the letters and keys that we want to output, we're essentially going to run the main loop, which will essentially activate the GUI. So here we're going to run this code. We have this window popped up. You see that we have the text from the label displayed here. And when we press a button and any number, we can print it out as so. So in order to output this to the serial port, we're going to go ahead and uncomment the serial commands from the serial library. Here you can basically write whichever COM port you want to output to, along with the rate and the timeout if you have one. So instead of just printing to the console, we want to actually write to the serial port, and then we're going to close it at the end of the code.
Alright guys, so in this section we're going to be talking about the Arduino code that we need for our remote control car in order for it to communicate with Matlab on a laptop. In order to get started, we need to declare a couple of libraries that we're going to use. So we're going to use #include, and then this first one is for our motor controller, the motor shield that goes on top of the Arduino Uno. And then the second one is for software serial, which is what we're going to be using to communicate with the XB. You're going to need to set up an RX and TX pin on your Arduino. In this case, we're using pins number 3 and 2 for RX and TX respectively, and set those up as a constant integer. And then we're going to use a software serial command and a line called XB. Next, we're going to declare an object called MD, and it's of type dual MC33926 motor shield. This is specific to the motor shield that we're using for our motor controller. And in our setup function, you're going to start out by beginning communication with the XB at a baud rate of 9600, and we're also going to initialize the motor controller. And now that you've created an object called MD, that's what we're going to reference in the rest of our code. So the initialization of our motor controller is simply md.init and then open brackets. Alright, and so now we go to our main loop, and this is the loop that's going to run over and over again as it continuously reads commands from Matlab. So we're going to start out by saying if XB is available, xb.available. If that is true, then the command that we want to read in is equal to xb.read. So we're reading in the latest command from the xb. Now once we have that, and command is a character which we initialized at the top of our code, doesn't really matter what you initialize it to. In our case we just set it to n. You'll see why in a bit. But every single time this loop runs, we're going to be redefining that command. So it really doesn't matter what you set it equal to at first. So let's say that the command that we get from the xb is the character 1. In this case, we're just going to take that and we're going to set it equal to, we're going to set our velocity equal to 1/9 of 400. The reason why we're using 400 is because that's the maximum value that we can set the speed at for the motor on the motor controller. We basically want some number in between 0 and 400. So if we send 1, we say we want it to be 1/9 of 400. If we send 2, it'll be 2/9, 3/9, 4/9, and so on and so forth. So basically we're scaling our motor speed from 1 to 9, and that's telling our motor controller that we want it to go from 0 to 400. So that's one of the simplest ways to tell it how fast you want it to go. And in each case, we're saving that number to a variable called velocity, which we initialized up top as a double. And again, up here, we just set it equal to 1 when we initialized it. It really doesn't matter what you set it equal to. Next command is if we send the letter n, or if the character n is received from the xb, that just means we want the remote control car to stop completely. So in that case, we're just setting the speed equal to 0. And this is the actual command that you use to set the speed. It's md, which is the object that we initialized up top, right here. md.set m1 speed, and then parentheses. Now this number 1 and number 2, that's just the motor identification. So motor number 1 is going to be whatever motor is plugged into the number 1 port on the motor controller, and the same goes with number 2. Now as we continue down, let's say that the command that we get from the xb is S. We are using the keys strokes A, W, S, and D for forward, backward, left, and right. So for S, that means that we want the car to go backwards. Now one thing you have to remember is that when we actually constructed this remote control car, the polarities of the motors are going to be flipped, because one motor is facing one way and the other motor is facing the other way. It actually depends on which way you plug it into the motor controller itself. So this may take a little bit of trial and error. So in our case, in the ways that we plugged in our motors to the motor controller, we actually need opposite polarity in order to go one way. So in order to go backwards, we have to say motor number 1, go forward at this velocity, and motor number 2, go backwards at the same speed. Whatever velocity you set up here, one of them is going to be positive and one of them is going to be negative. And you're using the same command as before, md.set m1 speed or md.set m2 speed. Now we continue down. If we receive the command W, that means that we want it to go forward. So intuitively, that's just going to be the opposite of going backwards. So M1 is now going to be going in the negative direction, and M2 is going to be going in the positive direction. We receive the command A. In this case, it means we want to go left. Just the way that we wired our motors to our motor controller, it means that both of them are going to be running in reverse. And intuitively, that means if we want to go right, then both of them are going to be running forwards. So you can see that this same command, md.set m motor number speed, is used pretty much throughout this entire code. And last but not least, let's say we want to escape the program. We basically don't want to be able to command it any further. If we receive the letter Q, that means that we're just going to go into an infinite while loop and nothing else is going to happen. We're basically going to be stuck in that while loop for the remainder of the trial.